Hi. In this problem, we are going involving circles and lines. It's a coordinate geometry question, which is a good one for JEE Advanced. So let's try it out. So it says, if a circle C naught with radius 1 touches both the axis, and the line L1 passing through P, which is 0, 4, and the circle. So the circle with C naught with radius 1 touches both the axis, and the line passing through P 0, 4 cuts the x-axis at x1, 0. So the circle touches both the axis and it also touches the line L1, and the line passes through P and cuts the x-axis at x1, 0. Now again, a circle C1 with radius 1 is drawn touching the x-axis, the line L1, and another line L2, through P. Now this L2 line intersects the x-axis at x2, 0. The question is asking us to find the value of x2. Okay. So first of all, we need to understand the question and try to represent it with a diagram. So this is the situation. There is a circle of radius 1 that touches both the axes. So it should be like this, a circle like this. It has radius 1, and since it touches the axis, the center would be 1, 1, because this is perpendicular, and these are radiuses. So this center will be 1, 1. And it touches line L1, which is passing through 0, 4. So let's say this is the point P, which is 0, 4. This is the line L1, and the circle touches the line, and the line L1 intersects the x-axis at x1, 0, right? Now we have to draw another circle which touches the x-axis and touches the line L1 also, right? So these two are tangents to the circle. So something like this. We have another circle. This is my circle C2. It touches L1 and it touches x-axis as well. And there is another line from P which also touches this circle, right? This is also line L2 which touches the circle, the second circle. So basically there are three tangents to the second circle, L1, L2 and x-axis. And this is the point x2, 0, which we have to find, right? So that is the problem. Both the circles have radius 1. And you know everything about the first circle because you know the center of the first circle is 1, 1, right? Okay, so let's think about how we will do this problem. So first of all, notice what we know about the line L1. The line L1 we know passes through 0, 4 and also passes through x1, 0. So the x-intercept and the y-intercept of the line would be x1 and 4. So we can say, I will draw the figure here also roughly. So we have a circle like this, a line like this, another circle touching this, and another. Okay, my figure is a little incorrect here. So circle like this, line probably from higher up, like this. This is my line L1. Another circle like this, touching both L1 and x-axis, and another line from here. And this is my x2. This is the point x1 comma 0. This is the point P, which is 0 comma 4. And the circles have radius 1, right? Okay, so equation of line L1 can be written in the intercept form, because we know x-intercept is x1 and y-intercept is 4. So it is x by x1 plus y by 4 equals 1. Similarly, equation of line L2, it also passes through this point and it passes through this point. So that will be x by x2 plus y by 4 equals 1, right? Now, remember, because this circle touches both the coordinate axis, the radius of the circle is 1. The center of the circle is also known. Circle 1 is x minus 1 whole square plus y minus 1 whole square is equal to 1. Circle 2, we don't know the center completely, but we know that this is 1 and this is a radius. So the center must be at a height of 1 from the x-axis, right? So therefore, center of this circle has to be some h comma 1 and radius is 1. So it will be x minus h whole square plus y minus 1 whole square is equal to 1, right? So these are the two circle equations. And now we have to figure out how to find this point, right? Now here, I will try to avoid doing geometry, doing coordinate geometry stuff like equation of pair of tangents and all. I will not try to do that. We will use geometrical results because that will give us the answer faster. So what do I mean by geometrical results? We mean that if a line touches a circle, if a line touches a circle, then perpendicular from center to the line has length equals radius of the circle. So this is a geometrical result that is always true for lines being tangent to circles, and this will give you the answer faster in most situations. It will be faster than trying to find the point of contact and all. If anybody tries to find the points of contact and all, they will take a long time to solve this problem, right? There is a lot of tangencies present here. For example, line L1 is tangent to circle C1. L1 is also tangent to C2. Line L2 is also tangent to C2. And these things, you don't need to find the lines or to find the points of intersection or all. What you need to do is the geometrical result that perpendicular from center of the first circle from 1 comma 1 to L1 should have length of 1. That is the first result, right? The second result that you can say is perpendicular from center of the first circle, or center of the second circle from basically h comma 1 to L2 is also having length 1. This is the second result, and the third is perpendicular from center of second circle to L1 is also going to have length 1. I told you there were three tangencies, right? L1 is tangent to both C1 and C2, and L2 is tangent to C2. So you have three conditions like this, and let's see what will come if we apply these conditions. So I will do it here only. The first result is perpendicular from 1 comma 1 to L1 is having length 1. So from there, we will get this equation 1 by x1 plus 1 by 4 minus 1 mod root over 1 by x1 square plus 1 by 16 should be equal to 1, right? If you simplify this a little bit, what you get is 1 by x1 minus 3 by 4 whole square is equal to 1 by x1 square plus 1 by 16, right? Now solving this equation, take the square here, you will cancel the 1 by x1 square term and you will get an equation like this: 9 by 16 minus 3 by 2x1 is equal to 1 by 16. And from here we get 3 by 2x1 is equal to 1 by 2. So therefore, x1 is equal to 3, right? So x1 is coming out as 3, and we basically got the value of this x1 simply by doing this condition, right? Okay, so we'll use that now. Now what we will do is perpendicular from h comma 1, which is the center of the second circle, to line 2 is going to have length of 1, right? So let's do the perpendicular from h comma 1. So we will say h by x2 plus 1 by 4 minus 1 modulus divided by root over 1 by x2 square plus 1 by 16 is equal to 1. So you get a similar equation like the previous time, and we are getting mod of h by x2 minus 3 by 4 is equal to basically 1 by root over 1 by x2 square plus 1 by 16. So that is one condition that I get. Also perpendicular from h comma 1 to line L1 is also 1, right? Because circle 2 was tangent to both L2 and L1, right? So this is the condition for L2 line. Now I have to do for L1 line. So let me write the equation here. So the center is at h comma 1, and I will get, now notice this line equation is x by 3 plus y by 4 is equal to 1, because we already know x1 is equal to 3. So perpendicular from h comma 1, we'll get h by 3 plus 1 by 4 minus 1 divided by root over 1 by 9 plus 1 by 16 is equal to 1, right? So from here, I get the equation h by 3 minus 3 by 4 modulus is equal to 1 by 9 plus 1 by 16 would be 25 by 144. So that would be 5 by 12, right? So this is coming as 5 by 12. So if I solve it, h by 3 minus 3 by 4 is equal to 5 by 12. I am getting h by 3 is equal to 5 by 12 plus 3 by 4. So that will be 14 by 12, which will be 7 by, h by 3 is coming out to be what? 5 by 12 plus 3 by 4. So 3 by 4 is 9 by 12. So I'll get 14 by 12. So 3 cancel, 14 by 4. So h is coming as 7 by 2 here, right? And if h is 7 by 2, I can put that in this result, right? Notice, by the way, that here I could get a minus 5 by 12 also. But if you do minus 5 by 12, your h value comes as 1, which will be rejected, because this is not the first circle. This is the second circle we are talking about, right? So the other value is rejected because based on the figure, h is equal to 1 doesn't make any sense, right? So we have gotten our center of this circle. It is 7 by 2 comma 1. And now we use that result in this to find x2. So you get 7 by 2 x2 minus 3 by 4 mod is equal to root over 1 by x2 square plus 1 by 16, right? I will square it and solve this problem now. So I'll get 7 by 2 x2 minus 3 by 4 whole square is equal to 1 by x2 square plus 1 by 16. If you simplify it, you get 49 by 4 x2 square plus 9 by 16 minus 21 by 4 x2 is equal to 1 by x2 square plus 1 by 16. And simplifying this, I get the equation 45 by x2 square minus 21 by x2 plus 2 is equal to 0. And clearly this can be factorized. 45 by x2 squared minus 15 by x2 minus 6 by x2 plus 2 is equal to 0. The factorization is 3 by x2 minus 1 times 15 by x2 minus 2 is equal to 0. Now remember, we had already gotten x1 was 3, right? So x2 cannot be 3. So this factor doesn't give us the correct answer. Based on our geometry of the problem, x2 has a bigger x coordinate than x1, right? So you'll get x2 is equal to basically 15 by 2. And that is our answer. So notice what we did here. How did I find x2? All I did when I had to solve this problem was apply three conditions. There are three tangencies. Line L1 is tangent to circle 1 and circle 2, and line L2 is tangent to circle 2. The three conditions that I did was perpendicular distance from centers of these circles to these lines. And those perpendicular distances must be equal to the radii of these circles. There is another hidden fact here that we have already utilized. The fact that the circle center for the first circle was 1, 1. That comes because it was tangent to both x and y axis. So it should be obvious that whenever a circle touches both the axes, this is a perpendicular line from the point of tangency, and that will be passing through the center. Similarly, this is also going to pass through the center. So the intersection of these, since the radius has to be 1 and 1, this point has to be 1, 1, right? So therefore, we got the center of first circle as 1, 1. And because the second circle touches the x-axis, we got center of the second circle as h, 1. Because the height of the circle has to be 1. Y coordinate of the center has to be 1. So geometrically solving a problem will make it faster. If you try any other approach here, it might be too long for you to simplify. So try to keep that in mind while solving coordinate geometry problems. Draw the figure always, try to visualize what is happening, and try to write as many geometrical conditions as you can, right? That will help you save time in the exam. That's it. That's what I wanted to show you in this problem, and I'll see you next time.